right, welcome back. We are moving on. So we are still in the kidneys and we are looking at the functional units of the kidneys called nephrons. And what are the nephrons doing? Well, first of all, you have millions of nephrons in each kidney. In fact, you have enough nephrons in one kidney to do the job of filtering the blood. So that explains why we could donate a kidney and still live a completely normal life. If we look at the structure of a nephron, we could kind of break it down into two parts. There's the blood parts, the blood vessel parts, and then there's the tubes, right? So remember, the nephron's job is to filter waste products from the blood. So there has to be blood vessel parts that are entering into the nephron, bringing that unfiltered blood in. All right, so just imagine that the blood is going into the kidney unfiltered. It goes into the nephron. A couple things happen, and then the filtered blood leaves the kidney. So the blood is very different going into the kidney compared to coming out of the kidney because there's wastes that have been removed. Those wastes end up being your urine. All right. So there's a lot of different parts. If you look at this slide and the next slide, just lists all the different parts. The afferent arteriole, Bowman's capsule, glomerulus, efferent arteriole, proximal convoluted tubules, loop of Henle, distal convoluted tubules, collecting tubule. Those are all the main parts. And let's see. Let's take a look at the actual structure of a nephron. It looks kind of messy. There's a lot going on, but let's see if we can explain this here. So the afferent arteriole is a small artery that stems from the renal artery. Right, so the renal artery brings the unfiltered blood into the kidney. And then the renal artery branches many, many times, and the unfiltered blood eventually finds its way into what's called an afferent arteriole. The afferent arteriole is going to bring the unfiltered blood into the first tubular structure of the nephron, which is called the glomerular capsule, right? Or Bowman's capsule. So what's going on in here is this is a network of capillaries. So the blood is spinning around and around and around in this circular network of capillaries. As the blood is spinning around and around and around in there, all the waste products of the blood are being removed from the blood and being caught by this capsule, this Bowman's capsule here. So all the things that were in the blood are coming out and draining into this area. Now, this is going to be eventually urine, but the problem with this is not only bad things are coming out of the blood, you have good things in the blood too. And some of those good things just came out, right? Things like amino acids and glucose, stuff like that. So the blood just lost all the waste products, but also some good things. So now what the blood is going to do is going to leave this area, going through the efferent arteriole, and it's going to try to get some of those good things back. It's going to go over to this section, this first section of the tube, which is called proximal convoluted tubule. Remember, proximal means closer, right? So closer to the glomerular capsule, the tube becomes the proximal convoluted tubule. So this is where the filtered blood is going to be going, and it's going to pick up the things that it dropped off that it needed, things like glucose, water, amino acids, whatnot. All right, so then the filtrate, which will be the urine in these tubes, will extend down into the medulla region of the kidney, all the way down through these tubes. This is called the loop of Henle. So this is the descending loop of Henle. And then it's going to turn and go back up through the ascending loop of Henle. And eventually it's going to enter into what's called the distal convoluted tubules. Remember, distal means further away from the beginning. And it's here that the blood is going to drop off last minute items that it couldn't drop off over here, things that are larger, um, like prescription drugs or that kind of stuff. Um, Steroids, if they happen to be in your body, would be dropped off here. And then all this filtrate drains into this collecting tubule. And the collecting tubules all converge in the renal pelvis, and this is going to be urine. So urine would be the product at the end of this process here. All right, so what do we need to know really? So the unfiltered blood comes into the kidney, spins it around and around, right? Products are coming out. The blood then takes what it wants back, and then it leaves the kidney through the renal vein filtered. And then all these waste products go through these tubes and drain into the collecting tubule. And then all the collecting tubules converge in the renal pelvis, and then the urine drains into the ureters and gets stored in the bladder. All right. So this is the pathway of urine as it's formed in the glomerulus, from the glomerulus, between the glomerulus and the Bowman's capsule. So obviously the blood is not filtered. The blood that is unfiltered enters into the kidney and spins around and around and around the glomerulus. So the filtrate, which will be the urine eventually, is found in the Bowman's capsule. All right. From the Bowman's capsule, it'll drain into the proximal convoluted tubules. And then from the proximal convoluted tubules, remember, it goes down the loop of Henle and back up before it drains through the distal convoluted tubules. It's in the distal convoluted tubules that we have that last minute drop off of larger waste products, things like larger drugs, stuff like that. Until finally, all the filtrate drains into the collecting tubule. Now this, once inside the collecting tubule, this will be urine. All right. So the formed urine will then go from the collecting tubule. This is an interesting factoid here. It says, by the time it reaches the collecting tubule, most of the filtrate has been taken back by the blood, right? Because if you think about blood, most of the blood is good stuff, right? Only a small amount of stuff inside the blood is waste. So when we send the blood into the kidneys and everything gets removed from the blood, well, most of that stuff has to get put back. Only the waste products are being sent out of the body as urine. So then the urine drains down into the renal pelvis through the ureters, stored in the bladder until it's time to exit the body. And then it exits through the urethra, through the urinary meatus. All right, so we do have three processes happening here in the production of urine. The first process happens between the glomerulus here and the glomerular capsule. And this process is called filtration. So this means that the blood goes in and all the stuff gets taken out, right? A lot of things: water, salt, nitrogen, waste products, glucose, amino acids, right? All vitamins, minerals, all these different things are coming out of the blood. Some of them are wastes, but some of them aren't, all right? So when we get over to the proximal convoluted tubules here, this is where reabsorption happens. So most of those good things that were taken out of the blood are now getting put back into the blood. And then again, secretion happens in the distal convoluted tubules. This is where larger items that couldn't leave the blood over here, that are still waste products, are getting dropped off through active transport towards the very end of the process. All right, so here in this picture, this is a nice image. We see the afferent arteriole bringing unfiltered blood into the glomerulus, and then the glomerulus is a network of capillaries that allows the blood to spin around and around and around. And what that does is that forces the substances that are in the blood out of the blood, right? So you can see these little dots here are products that are in the blood. So these products end up in this capsule, the glomerular capsule or Bowman's capsule. And then these products find themselves in the proximal convoluted tubules. And you could see it's in proximal convoluted tubules that reabsorption is happening. So a lot of these products are going right back into the blood. So this would be stuff like glucose, maybe water, certainly amino acids. All the things that we don't want to lose would go just right back into the blood. And then this blood, filtered blood, will then leave through the efferent arteriole. All right. You might want to watch this a couple of times. And I know it's a little tricky, but those are nephrons. These are the functional units of the kidney. So these are the actual things that are filtering the blood. All right. Okay. Bye.